today I'm going to solve the problem what I call separation of variable. As you can see, we have variable in X and variable in Y. Basically, we're going to put everything with Y on one side and everything with X on the other side. So to do so, we're going to divide that side by Y times B minus Y. So in this side, this is what we're going to have. Equal to x squared minus 4. As you can see, we have everything here with y and y prime, and everything here with x. Basically, now y prime is basically dy over dx. Right? So what we have here is dy over y dx. Perfect. Just multiply dx like this one and then keep my dy. Now I have the dy dx here, so I integrate both sides. This one is a piece of cake, so we're gonna do this one first. So if I integrate this one, I have x cubed over 3 minus 4x plus c. This one's gonna require it's a little bit challenging. This one. Yeah, like I was saying, this part is a little bit challenging because we're gonna do what we call partial fractions. What we have here
with the curve, you got like 70 or 80 something. I got like 50, 60 something with the curve. Yeah. I was like, booty boo! Nah, that shit made me so happy. This and that. Like, more than
partial fraction is essentially trying to write that thing I have here in terms of the A and B, right? So basically what I'm going to do now, I'm going to multiply the entire thing by the denominator. If I multiply everything by the denominator, I have 1.
Nope. I'm like, motherfucker, can you please?
Then,
you was pissing me off. Then the Indian dude was catching me breaks, so I was like,
if I multiply this one, the y cancels, so this one. So I have by here. So my goal is to find A and B. So I can arbitrarily take some values for y so I can have A and B. The first thing I will do is I want to cancel that one. I take y equal to 0. So if y is 0, like this one cancel, and then this one I will have A equal to 1/3. And similarly, if y equal to 3, if you put 3 here, you have 0 here, 3 here, so b is also 1/3. So I can go back there and I say it's 1/3, 1 over y plus 1 over 3 minus y. Remember, I haven't integrated that part of the equation. So now I'm ready for it. So it's 1/3. I know what is that. It's natural log of y. But this one I have -1, a negative y at the bottom. I should have -1 on top. But I have a -1, I put a negative. Let's put the negative outside. So when I integrate this one, it will be negative 3 minus 5. Now I can multiply everything by 3 so I can get it, and then use the log laws to put that in a really nice fashion. It will be naturally alright. 3 minus 5. If I multiply everything by 3, the 3 here gone. So I have 12x here. Plus, that's 3c, but since c is a constant, 3c is the same thing as c. I'm not going to multiply by 3. Now, I'll call it to 5c, so yeah, y, 3 minus y. Right, I'm going to move everything. So plus 12x minus x cubed. Oh, that's practically over, but remember we have an initial condition. Initial condition is say when x is 0, y is 2. I'm going to plug when I have y, I'm going to put 2. I have x, I have 0, I put 0. So this one is 0. So c will be natural log. If I put x, this is 2. 3 minus 2 is 1. So it's just natural log of 2. So some teachers want you to go all the way and then to have y with respect to x. As you can see, because you have natural log, you're gonna have exponent. But some teacher, again, you can just put it the way it is right here. Just replace natural log of c. Natural log of 2 for the constant. So what we're gonna do here, we're gonna say, remember c. So we now have c. So it's natural log of 2. Go to the natural log 3 minus y plus 12x minus, and that's your solution.